Welcome back, ladies and gentlemen, of my physical science class. Mr. Hescox coming back to you today. We have been talking about chemical reactions and all the different things in chemistry. One of the last things we did was speeding up or slowing down rates of reaction. We're going to pick up with talking about how we change the rates of reaction. And then we're going to start talking about something called the law of conservation of mass and why we have to balance our chemical equations. Stick with me. I have a lot of practice in this section because this is probably one of the harder sections of the whole book. So we'll do some practice, and then if you need to, you can always come back and watch this video again. So will it increase or decrease the rate of reaction? So you guys at home can use your thumb. I'll just use an arrow up or an arrow down. If I heat the reaction, will that increase or decrease? Well, it should increase our reaction. If I add more reactant, if I put more wood on the fire, I will increase the rate of the fire. If I cool the solution, well, cooling is going to slow those particles down. It's also going to decrease the reaction. Making pieces of the reactant smaller, in other words, breaking it up. If I break it up, I actually increase the surface area. So in that case, that's going to increase our reaction. Stirring it causes those particles to collide faster and increase the rate of reaction. And finally, adding an enzyme catalyst, enzymes are going to increase the rate of reaction. This gentleman is Anton Lavoisier, and he came up with the idea that the masses at both sides, the reactants and the products, must be equal. So we used to think that if you burned wood, that the wood was basically gone and all that material was actually gone, so we had destroyed it. Lavoisier concluded that the masses of the reactants and the reactants of the products must be equal. So after you burn wood, you have ashes there. If you had the mass of the ashes plus the mass of the smoke, it would equal the original amount of mass in that piece of wood. We call this the law of conservation of mass. Matter cannot be created nor destroyed in a reaction. The atoms in the reactants must be present in the products. In other words, you have to have the exact same number of reactants. To do this, we use chemical formulas, and we balance those chemical formulas with what we call a subscript. Oh, not a subscript, a coefficient, excuse me. So we use these symbols called coefficients. You can see here at the bottom, the coefficient in front of the water is a 2. That means it's 2 water molecules. That tells you that that's how many molecules you'll have, or it can tell you how many of an individual atom there are. You cannot change subscripts when you're balancing equations. You can, however, change coefficients to balance equations. Some tips, and we'll do some practice ones here in a minute. You count the number of atoms on each side, then use a coefficient basically to multiply one atom or another until it equals out. So let's take a look at this one here. This is methane gas plus oxygen gives you carbon dioxide and water. So one of the ways that I like to show this, well, I've got one carbon here, one carbon there. So that's balanced. Here I've got 2 oxygens, 2, but I've got 3 oxygens on this side. So I need to come up with a number and how to get there. Well, I only have 2 oxygens here, so I write my 2. I have 4 hydrogens here. And over here I have 2 hydrogens. Well, normally you would start with your oxygens first, but in this case it becomes easier if you balance the hydrogens. So I've got 2 hydrogens here, 4 on this side. What can I multiply 2 by to get 4? Well, if I put a 2 in front of this hydrogen, that'll give me 2 times 2 is 4. I've got 4 there, so those are now balanced. My carbons are already balanced. So I've got 2 oxygens here, and then 2, I have to multiply that over here. 2 times 1 is 2. I now have 4 oxygens on this side. I have 4 here. I have 2 oxygens here. What can I multiply 2 by to get 4? If I multiply this oxygen by 2, 2 times 2 is now 4, and we have balanced this out. So you would need a coefficient of 2 in front of the oxygen, a coefficient of 2 in front of the water. So we're going to try a couple here, and this is actually from your homework paper. So I've got sodium plus oxygen gives you sodium oxide. Well, what I like to do, put a line. I've got 1 sodium here. I've got 2 oxygens. Here, my sodium, I have 2 of them, and only 1 oxygen. So in this case, we're going to try and balance those oxygens first. We've got 2 on this side, 1 on that side. What times 1 is 2? Well, 2, right? 2 times 1. Anything times 1 is itself. So if I put a 2 in front of that oxygen, I need to put a 2 in front of the molecule sodium oxide. That's not a molecule. Well, now I have 2 times 2 actually equals 4. So here, get rid of my 2. Now I have 4 sodiums. I have 2 oxygens, which balances those are done. Now I have 4 sodiums. What times 1 is 4? What can I multiply 1 by to get 4? Well, in that case, I need a 4. So I have 4 here. 4 times 1 is 4. 4 on one side, 4 on the other, and it cancels out. The next one is a super common one. This is hydrogen plus oxygen yields water. So split them. I've got 2 hydrogens, 2 oxygens. On this side, I got 2 hydrogens, like 1 oxygen. So I've got to get balance of my oxygen. If I have 2 oxygens on this side, I got to multiply this side by 2. When I multiply that side by 2, 2 times 2, this now gives me 4 over here. 4 hydrogens, 2 oxygens. 2 oxygens are now balanced. I've got 2 here and 4. What times 2 equals 4? Got to multiply this side by 2. 2 times 2 is 4. That cancels there, and that cancels there. We can do another one here. You have sodium sulfate plus calcium chloride gives you calcium sulfate plus sodium chloride. So what's nice here, and you don't see it, sulfate is a polyatomic ion, and this tends to stay the same, so you can treat that as one whole atom, SO4. You can treat that as one atom. I've got 2 sodiums. Here I've only got 1 sodium. I've got 2 chlorines here. I've got 1 chlorine over here. I've got 1 calcium on each side. 1 calcium there. So my sulfates, 1 and 1 are the same. Calcium, 1 and 1 are the same. But I've got 2 sodiums on this side and 2 chlorines. Here I've got 1 and 1. What can I multiply 1 by to get 2? Well, you multiply the whole thing by a coefficient of 2. 2 times 1 is 2. 2 times 1 is 2. That means these two chlorines cancel out. My calciums cancel out. The sulfates cancel out. My 2 times the sodium cancel out. And that gets us to just needing a 2 is the only coefficient that you need there. All right, ladies and gentlemen, we're going to do this fourth one, and then we're going to call it a day. Here I've got 2 aluminums. And then I've got oxygen, I've got 3. Over here, I've got aluminum of only 1. And I got 2 oxygens. Okay. Now this is one that's not quite as easy. The trick to this one is that you need to get a number that 2 and 3 go in. What is the only number that 2 and 3 go into? It's relatively small. Well, that's going to be 6. So how can I get 6 oxygens here and 6 over here? Well, if I already have 3, what can I multiply 3 by to get 6? I'll multiply this by 2. So if I multiply that by 2, I put a coefficient of 2 up here. That'll give me the 6 oxygens. And that changes my aluminums to 4. Here I have 2 oxygens. To get to 6, what can I multiply 2 by to get to 6? I multiply this side by 3. So I need 3 oxygens here. So 2 times 3 is 6. Those cancel out. 3 times 2 is 6. They cancel out. I've got 4 aluminums here, only 1 on this side. What times 1 is 4? I need to multiply that by 4. I put a 4 there, cross that out, and those, ladies and gentlemen, are how we balance equations. Nothing on your test is going to be super hard, but there are a couple in there, and we'll be practicing throughout the day tomorrow. And this is just in case you guys need a little extra help at home. And until next time, make sure you guys get that section of questions done and get that reading done. I'll see you later. I'm Mr.